Hey, it's recording. So we are moving on today. I see it went down. Okay, here. The notes. Is where we are. Adding and subtracting and multiplying. Adding, subtracting, multiplying radical expressions. Okay, so one thing I want you to know is when we're adding and subtracting radicals, the inside must match. So the radical has to match. So if it's a square root, the other one has to be a square root, and the inside has to match. For example, if you have 11 square root of 3 minus 4 square root of 3, that's a 3. Okay? Do they match? They both have a square root with a 3, so they match. What's 11 minus 4? 7. Good job. Okay. So you'll notice that they stayed the same. The radicals stayed the same. The only thing that changes is the number in front. It's almost like variables, y'all. If this was 11x minus 4x, wouldn't it be 7x? Yeah, same concept. Okay, so knowing that, your insides must match. Look at number 1. Do the insides match? Yeah, and they're both 4th root. So what is 3 plus 7? Now, oh, I forgot the P. Okay, make sure y'all's little 4th roots look little. Okay, some of y'all are writing it like this. Okay, and it looks like you're writing 104 square root of PQ, or 11 PQ. Do not write it that way. You have to write the 4 little. Yes? Some of y'all also copy wrong.
It's blurry.
Whoa. Okay, yeah, me too. Okay, look at number 2. Now, these are not simplified. You have to simplify these. So, first off, can we always use our calculator first to make sure? Yeah, because what if it's pretty? Do you really want to do the factor tree if you don't have to? No. How do you do cube root? Math 4. Okay, math 4, 64. Is it pretty? Yeah, so I'm going to take out a 4, and I'm going to cross out the 64 so we know we're done with it. Now, this is like we did last week and the week before. How many times does 3 go into 4? Once, and how many do you have left over? 1. Because if you have 4 m's, 1, 2, 3, 4, I'm looking, because it's a cube root, I need 3 of them to match to take it out. Well, 3 of them match, so I took it out, and how many did I have left? 1. Does that make sense? So if I have 5 n's, 1, 2, 3, 4, 5, a group of 3 comes out, so I can take 1 n out, and how many do I have left? So n squared. You good? Okay, so then it says minus, so I'm going to put a minus. And I have cube root of negative 27, so cube root is math 4, negative 27. What do I get? Negative 3, and there's no decimals, so it's a pretty number. I didn't have to do the factor tree at all. So knowing that, how many times does 3 go into 10? 3 times with 9, and how many do you have left over? And then how many times does 3 go into 12?
4.
With what left over? 2 negatives make say? Now, do these match? But are the first parts like terms? Therefore, this cannot be simplified even though they match, because these are not like terms. So there's another way you could write it. If you left it like this, I would accept it. You could also write it for mn plus 3m cubed n to the 4th. So you could also write it like that, and I would accept that as well. So like I said, I'll accept either of those as your answer. No, the ones on your practice simplify. So you won't have to worry about that. Okay. So let's look at number 3. Okay, we're actually going to edit number 3 because this is a Ms. Cumberledge mistake. These should be to the 1/2 power. What does the 1/2 power tell you to do? The bottom numbers are starts with an R. Root. And the top number is your exponent, right? So this is a square root of 75. Do I have to put the exponent of 1? No. Okay? Minus the square root of 147. Do they match? No. So we're going to factor tree them, yes? So 75. What goes into 75? 5 15 times. 5 also goes into 15 3 times. And because it's square root, I'm looking for pairs of 2. So here's a pair of 2 5s. So I can take that out. And what was left over? Y'all remember how to do that? Okay, and then I have 147. What goes into 147? 2 doesn't. But 3 does 49 times. Isn't 49 a perfect square? 7 times 7, right? So I know I have a pair of 7 and a 3. So this is going to be minus 7 square root of 3. They both have square roots. And they both have the square root of 3. So can I combine the front? The coefficient. What's 5 minus 7? There's your answer. Okay, let's look at example 4. Now what are we doing? So that was adding and subtracting. Now we're multiplying. Okay, multiplication's a little different. Okay, so what I want you to realize is that when they're both in the house, you can combine them because they're both square roots. So here, what's the square root of 3 times 5? Well, those aren't like terms, so we're just going to set them next to each other. Almost as x times 5, wouldn't that just be 5x? So this is just 5 square root of 3. Yeah, because the square root always goes after your whole number. Okay. Plus, well, these are both inside of a square root, which means we get to combine them. What's 3 times 30? 90. Can we simplify the square root of 90? Yes, I know y'all love this. Okay, what goes into 90? 3. How many times? 3 goes into 30 10 times. 2 goes into 10 5 times. So I have a pair of 3, and then the 2 and the 5 don't have a pair, so they get to go back in the house. So I have 5 square root 3 plus 3 square root what? 2 times 5 is 10. Do those simplify? So there's your answer. Because this is square root of 3, this is square root of 10. They're not alike. Because of the pair of 3's. We're going to do more subtracting. Hold on. Okay, look at number 5. They're both square roots, and it's multiplying, so can I combine the insides? Yes, because it's multiplying. So, what's 5 times 2? Then I have x cubed y squared. Those are not the same bases, so they don't simplify, so we're just putting in both of them. Now remember, when there's no number in front, it's a square root. So we could try to break down 10. 2 goes into 10 5 times. Well, those are prime. Do they match? No, so 10 is going to stay inside the house. X cubed, well, that just means X 3 times. And we're looking for a pair of 2. Do I have a pair of 2 X's? I have 1 pair, and how many left over? 1. Then I have Y squared, so I have a pair. Do I have any left over? So there's your answer. Okay, look at number 6. What does squared mean? I don't just square the insides. I can't do that. That would be great, but we can't. It means I have to multiply it by itself. So I get 4 plus 3 root 6 times 4 plus 3 root 6. And now what do we do with that? Double distribute. Okay, what is 4 times 4? Now, what's 4 times 3 square root of 6? 12 square root of 6. Treat it almost like it's 3x. 4 times 3x would be 12x, right? So just replace your x with the square root of 6. Okay. And then what is 3 square root of 6 times 4? 12 square root of 6 is the same thing. And now what about 3 square root of 6 times 3 square root of 6? Well, what's 3 times 3? And what's 6 times 6? Remember, they're both in the root and they're being multiplied, so you can combine them. Everybody okay with that? So now we're going to combine like terms. These two are alike, so I'm going to bring down my 16. What's 12 square root of 6 plus 12 square root of 6? 24 square root of 6. And now, isn't the square root of 36 a perfect square? What does it equal? No. So remember, I want you to realize this is 9 times the square root of 36. So if you're not sure, you can do square root of 36. I didn't mean to put a plus. And I get 6. It's not the square root of 6. It's 6. See how this has no house? So don't put the house back because it didn't have a house. So what's 9 times 6? 54. Now do I still have like terms? What's 16 plus 54?
70.
Any questions with that one? Okay, so let's look at number 7. We're actually not going to do number 8, but I'm going to do one from the practice. Okay, here, what am I going to do? Double distribute, right? Okay, so I have the square root of 2 times the square root of 8, and what does that give me? Square root of 16. Then I have the square root of 2 times negative 5. Well, a positive times a negative is a negative, and they're not like, so we're just putting them next to each other. Everybody okay with that? Okay, so then we have 3 times the square root of 8. Well, a positive times a positive is a positive. 3 times the square root of 8 is just 3 square root of 8. And then what's 3 times negative 15? I mean, dang it. 3 times the negative 5. Negative 15. I did. That's how my brain works, okay? My brain's keeping going. Okay, what's the square root of 16? 4. Are these like terms? Well, this guy doesn't simplify. Square root of 2, 2 is prime. That doesn't simplify. Does the square root of 8 simplify? 2. So what I want you to realize is 8 is 2 and 4 is 2 and 2, right? And I need a pair of 2 to take it out. Well, I have a 3 already there. And I want you to realize that's 3 times the square root of 8. Well, what is the square root of 8? 2 square root of 2, right? Yes? So what's 3 times 2? 6. And the square root of 2 comes down. I'm just going to bring this minus 15 down. And now what are my like terms? Well, 4 minus 15 is negative 11. And what's negative 5 square root of 2 plus 6 square root of 2? What's negative 5 plus 6? So plus 1 square root of 2. Yes. You do not have to put the 1 in front. Okay, we're going to do one of the practices together. So flip to number 7. One thing I do want to say on number 1 and 2, when you simplify these fractions, remember that number in front multiplies by whatever you're taking out. Yes? That like we just did. Okay, look at number 7. Okay, again, we're going to double distribute. Well, what do you notice about these two? Yeah, they're exactly the same except one's negative, one's positive. Okay? So we are going to multiply. What's 7 times 7? Now, a positive times a positive is a positive. And what's 7 times 2? 14. Okay, and then I have a negative times a positive, which gives me a negative. 2 times 7. And then again, I have a negative times a positive. And 2 times 2 is 4. What are my like terms? And what happens to them? They zero out. Because one's positive and one's negative and they're exactly the same. Now, what's the square root of 49? 7. And what's the square root of 4? And what's 7 minus 2? So when they look exactly the same except one has a plus and one has a minus, the middles are always going to cancel. Okay? Now, when they're squared, do the middles cancel? No, because they are exactly the same. These are not. One has a plus, one has a minus. That's why that middle cancels, because you have a positive and then you have a negative. Okay, so just be careful with that. Okay, so you're working on your practice. You have quite a bit of time this period, and then you'll have tomorrow.